everyone. Population increase. Depreciation is when we have fraction on the base. So how are you, everyone? Good. I'm glad to hear that. I'm also doing great.
I'm hungry though.
Hungry.
I'll grab one after.
Yeah, we should. We're almost done. Today is lecture 21. We have 7 more classes. And then we'll be gone from this class. Hopefully everyone will pass. Hopefully. I hope so. The good news is that we have 2 classes this week and also 2 classes next week. Even though we have Friday and Thursday off, but Wednesday next week is a Friday schedule. So we'll meet.
Is it still like lecture 21? Is that still 12.3 and kind of 8 as well?
12.38, those together. So we have, including today, 4 classes and then your exam. And my plan is to finish chapter 12 and 13 in these 4 classes so that you can have your exam on 12 and 13. Maybe we will not able to do 13.3, but my goal is to reach at least 13.1. So, any question from anyone before we start?
We're gonna have a final exam sheet, like, or we are providing.
We didn't have a review sheet for final. All of my in-class review sheets are sufficient for the final exam. So final exam is a bad one, right? So my plan is to get at least 3 days to do the review for the final exam. So if we have our exam on the 3rd, December 3, then we have 6, 10, and 13, yeah. 13 is our last class. Yeah. So we are doing application of exponential. Let me review a little bit from before. So we have 5 types of exponential equation. Based on what is given, we take different steps. For example, the first type is when you're the same base. We cancel the same base. We set the power equals to one another. We solve for x algebraically. The second scenario, we don't have the same base. However, we can rewrite the bigger base using the smaller base. So we do that, and we have the same base, we cancel them. And we do the same thing again. The next type is we don't have same base, but we cannot also rewrite the bigger one using the smaller one. Instead, we rewrite both of them into a smaller base. So we rewrite both bases into smaller bases, we cancel the same base, and we multiply our powers, set them equal to one another, solve for x. The next type was we have completely unrelated two bases, and our exponent is on our variable is on the exponent. So bring our exponent down, we apply log.
And this one is when we can cancel the bases.
We can't do anything with the bases. We cannot cancel them, we cannot rewrite them, we can't do anything. They're completely unrelated. So in order to solve for x from the power, we need to bring it down. So we ask help from the log, and we use ln, which is natural log, special type of log. Once we put log into our function, then power comes down. And then we solve for x algebraically.
And you say you only want us to use natural log, right?
Because of this. Because whenever we have E, we must use natural log. So I want you to have the same habit of having natural log for every cases. So the last step is we have more than two bases. We have E, we have 3, we have 16. So we cannot work with more than two bases. So we combine the constant together in one side and the other base alone. And then we have two different bases, completely unrelated. So we apply the log again. And ln is the enemies of one another. So they fight with one another, they will die, no more log term left. The power comes down automatically and is solved for us algebraically. Then we did some application. And we had two equations to work with. When you work with money problem, when you invest money, we have two scenarios. Either you invest with a certain compounding time, or you do compound continuously. If you do compound with certain number, like annually, semi-annually, monthly, weekly, like if you have some number of times you compound your money in a year, then it's the first formula, where n is number of times you compound. And if you compound continuously, so in your word formula, if you see the word compound continuously, it's automatically means you're using the second formula. And we have several scenarios. If the final amount is missing, we substitute everything into the formula and we just plug it into the calculator and get the result. If the initial amount is missing, then we solve for the initial amount. So we divide both sides by whatever we have in the P, and then we put the problem in the calculator that gives us the result. So you have to know how to use your calculator to find all the questions, solve all the questions, find the numbers for everything. Then what if the test rate is missing? Or what if the time is missing? Since time and interest rate, they both are the power. So anytime any of these are missing, means we need to apply log, because we need to bring them down. But we cannot apply log until the exponential term is alone. So you always need to divide by p to get the exponential term alone. And then we apply log to both sides. If r is missing, we solve for r. If t is missing, we solve for t. So only anything you're solving from the power, you apply log, otherwise it's simple algebra. So two scenario, interest rate or time, it doesn't matter, we apply log. And in this question, we are not compounding continuously, so we have to use a different formula, the first one. Anything we're not doing continuously means this one, annually means 1, so n becomes 1. And then we did second types of problem, where you're working with not money, but population. So when you're working with population, we have either the formula will be given to us, like this example, or based on the information, we are going to use the second formula, P into the RT. So in this example, the formula is given, and we found out the first one, found out the final population. In here, it says for how many years T is missing. T is on the power, so solve for T, we need to apply log. So we divide both by whatever number we have in front of T. When the exponential term is alone, we can apply our log. And now comes our last problem. A bacteria population is given by this formula. At what time the population will be 640? We are solving for time, but time is on the power. And guess what? This is non-calculated question. So you're not allowed to use calculator here. That means we need to apply the rules we learned from solving the 5 types of exponential. Actually, the first 3. The first 3 types, we don't use calculator. and the fourth and fifth one needs calculator. So this is from the first three types of the exponential equations. So they're telling us the population has a formula 10 times 2 to the e. We want to know the time, and they gave us 640. What is this 640? Which variable we need to substitute with 640?
The PT.
The PT, the final amount. So 640 equals 10 times 2 to the t. Dua? We cannot do anything until the exponential is alone. That's the rule. If you have a variable on the power, we need to have our exponential alone. So
Divide by
10 is a troublesome thing here. So I need to divide by 10. And you can see that you can cancel one of the zeros. We have 1 0 on the top, 1 0 on the bottom. We cancel them. So we have 2 to the t on one side. And what do we have on the other side? 64. Since you're not allowed to use calculator, what do you think our next step is? Please.
On both sides.
We cannot because 2 is the base.
I think we will write 64 as the power of 2.
Remember the second type of equation? When we have two different base, but we can convert the bigger base into smaller base.
It will be the 2 powers.
So if you multiply 2, how many times to get the 64? 6. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. So 1, 2, 3, 4, 5, 6. This thing is same as it's 2, 6 times. So we rewrite the bigger base in terms of the small base. And then what do you do? Since we have the same base, we cancel them. And this way we are so lucky, we don't have to do anything else. What is our t? 6. So we need to wait 6 years for the population to become 640. Oh yeah, they didn't mention the time. No, my bad. It could be hours. 6 years is too much. Bacteria grows really fast, right? I assume it's 6 hours. But since I don't know, let me not put any thing for that. The bacteria population at time t. Time t. Time means seconds. So yeah, after 6 seconds, which should be a bacteria. Any question? Was anything unclear here? Or confusing? With this, you're done with the real life application of exponential. I have a few more examples with their answers next to that, but I'm not going to go over with them. These are good practice for the final exam. What you're going to do now is going to the logarithm. So exponential and log, they're inverse of one another. We learned exponential. Now you're going to learn logarithmic. So before going to the logarithmic, let me refresh your memory about the exponential. 2 pages. Still one here, 1 page. So we said that exponential has a format y equals some type of leading coefficient a with the base b, and b has a power x. That's the format for exponential. Now this b, if it's more than 1, then we have an increasing function. If that b was between 0 and 1, means fraction, then we get a decreasing function. Do you remember this? Now this function, they have horizontal asymptote. Horizontal asymptote, we got them from the up-down shifting. So y equals up or down shifts. Do you remember this? Okay. And what else we said? So if you have y equals b to the x plus 1 minus 2, we have horizontal asymptote y equals -2. This is what it means, up-down shifting, because you're moving 2 down here, right? This is x. And what did we say about the plus 1? Left or right? So if it's plus, which direction you go? Left. Left one. And we also said every exponential without transformation has the y-intercept 1. Positive 1. Oh, drop it down. 1. Right? Now, logarithmic is inverse of this. That means if exponential has a horizontal asymptote, logarithmic has what type of asymptote? Can you guess? They are opposite of one another. So if one has horizontal, other one must have vertical. So logarithmic function has a vertical asymptote. If exponential takes the transformation up down for the horizontal asymptote, which transformation we are going to take for the logarithmic? So left and right. Left or right. So logarithmic will have an equation x equals whatever we get from here.
Would it be x equals b?
No, the horizontal, the vertical asymptote.
Yeah.
It will be y equals -1.
Okay.
Because you're going to the one to the left. So logarithmic will have something from x, and it will be x equals some number. And this graph has a y-intercept 1. Can you guess what would be the logarithmic intercept? X equals 1. Exponential has y equals 1. Log has an intercept x equals 1. Okay? So I'm telling you this beforehand to show you the connection between log and exponential, because they are inverse of one another. So if this is your exponential function b to the x, your log has the same shape, but the position is different.
Stephanie, it's called vertical.
So this is log of x. Exponential is growing very fast, but log function, they are growing very slow because they are opposite of one another. So this is our log function. log has the x value 1, x-intercept, where exponential had y equals 1 as y-intercept. Okay? So this has a horizontal asymptote, log has a vertical asymptote. And now you can relate them, like how they are connected. So in these sections, we are going to work with logarithmic. The first thing you're going to do is you're going to convert log into exponential. Because exponential is easy to solve. We have 5 scenarios for exponential, and we can solve them easily, right? Either we can convert the bases into same number, cancel them, or we can apply log. Now, logarithmic is harder to work with, so we don't like logarithmic that much. Whenever we have logarithmic, most of the time, we convert them into exponential. How do you convert? Can I change my slide? So, logarithmic equation has base. This is confusing. Let me let b here. Log base bx, which is same as b to the x, is y. So if y is log base b, and this thing we call them arguments. Argument or argument? I think argument. I always forget that. I think I have it in the next slide. Argument. Okay. So log has base b and something on the side. That side has a name, we call them arguments. Jannah.
So instead of the b being an exponent that is middle or the top, instead of next to the log,
Whatever we have on the leg of the G, we call them base for the log. So we write log, and on the leg of the G, we write some number. That number, we call them base. It is on the downside, it's on the base. So log has a base b with some type of argument next to that. If this is equals to some number, some variable, anything, this is a logarithmic form. We can rewrite the same form into exponential form by switching the position. B gets the power x, and is same as, it's equals to the argument. It's like a cycle. B goes to x, takes it as a power. Whatever we get, we set that equals a. So b to the power x equals a. Now this is we like because this is exponential. It's easier to work with. So log and exponential, they can be rewritten either way. We can write exponential into log. We can rewrite log into exponential, just by switching the position. But observe something. The base b is the same number here, base for log. So they both have the same base. Base for log is the base for exponential. Now whatever the log equals to is the power for the base. And whatever log has next is the y value for the exponential. If you get confused about this transformation, then let me show you another trick. Log has a property. That property says if you raise this log into some type of variable or some type of number, which is same as the base. So if we apply that into power of something, then they all cancel out. They all become one. So initially we have only log base b of a equals x. That is our initial equation given to us. Now we are raising both of them into some type of base.
You said if we have log base to a number and then we raise that, so that same base, it equals 1.
So if you apply base to both sides, since you have the same base on the log, so these three things will cancel out. All three things cancel out. What's wrong? All three things cancel out, and we get a equals b to the x, which is same as this one. So if you forget about how to convert, apply b to both sides on the base, and then whatever remains, that's the exponential format. Okay? Now have some practice. Rewrite all of these log into exponential format. Convert the logarithmic form into exponential form. Not calculators, these are just conversion. We are not doing any math, we're just converting them. All of these are log formats. So get rid of the log, convert them into exponential formats. It's not any math, okay? It's just conversion. Once you convert, you are done. You don't have to do anything else. For example, let me show you one here. We have base 6 on the bottom. So if you apply base 6 on bottom there, this cancel out. We get 4th root of 6 is 6 to the power 1/4. That's all you have to do. Equals. Square root of 5. If you're done, try the other way around. Rewrite exponential into log. And these are from the homework and quizzes. I'm helping with your quiz as well as with homework. Opposite, Julia. 12.5. Done? Okay, you try the right. And Stephanie, tell me the left. A.
The log one?
Uh-huh.
So for that one, I put 5 to the power of 1/2 equals the power of 5. What we did that? That's normal.
Yeah.
For that one, I got 3 to the power of -3, so 1/2.
1/27. So you can apply 3 to both sides. This cancel out. You have 3 to the power 3 is 1/27. This is one way of thinking. Other way of thinking is this. Now go the opposite direction, the reverse direction. Let him try. Go ahead. We have log So let's see, 6 to the power 1/2 is square root of 6. Perfect.
Wait, what was going here with the 5, when it's with the 5?
What I did is this, I applied the property. The property says if you have log base b of something equals y, you can apply base on both sides.
And then
If
the
you
top-
do that, the whole thing cancel out.
Right.
So you're left to it x equals b to the y. Okay, who'd like to try the next one? B, the reverse direction. Dua.
So 5, 8, 5,
Mm-hmm.
okay. Yeah, parentheses 1 over 5.
Mm-hmm. Wonderful. You can always check by going reverse direction. 5 to the negative 1 gives us 1/5, which is correct. See, we can go either direction. Log to exponents. We're not doing any math. We're just converting. Why? Because later we have to solve by converting them. So this step is a basic step. Just convert them, we are done. The next one, it's basically saying that log and base, so log and exponential, they are inverse of one another. So domain for the log function is the range for the exponential function. And domain for the exponential function is the range of the log function.
So this is like the inverse function.
The inverse of one another. And if x, let's say exponential has 0.12, then log will have 0.21. So they just reverse the position. Now, this is a log function, and this one is exponential function. Inverse function will reflect about y equals x length. About the asymptote, we said previously exponential has horizontal, that means log and have vertical. So log has vertical asymptote, so the equation for the vertical asymptote is x equals sum of 5. How do we get them, or where from we get them? We take the argument, we set argument equals 0, solve for x, that's our vertical asymptote. In other words, it's a left-right shifting. Just like exponential, if base is bigger than 1, then our graph, the log graph is an increasing graph. But if our base is a fraction, then it's a decreasing graph. And the bigger the number we have on the base, the closer it gets to the x-axis. For example, observe this log has base 2. So this is the graph. It has x-intercept 1. The purple one has base 3. So it's closer to the x-axis. The next one, black one, has base 10. It's even closer to the x-axis and closer to the y-axis. The last one is a 200 base. It's very close to the x-axis and very close to the y-axis. So the bigger the base, the closer it gets to x-axis and y-axis. Now we are going to do transformation. We are going to do the original graph first, and then we are going to transform. So we have a number next to the x. Which direction we are going?
Up and down.
Anytime you have a number next to x, the direction is
For left or right? I thought you
Left,
said it
right.
was inverse for the log.
The number, if we have a constant extra, that's the up-down shifting. But anytime, it doesn't matter which type of graph you're working with, anytime you have a number with your x, it's always left, right. So we are going to the left. So that's going to give us our vertical asymptote. We take this whole thing, x plus 2, we set it equals 0, and we get our vertical asymptote. So we take the argument, whatever we have next to the log, its name is argument. We take the argument, set it equals 0, and we get our vertical asymptote. Do we have any up-down shifting here? No, because there is no number which is single after the log. So we are going left. The original log graph goes to the x value 1, and this is the shape. This is log 2 of x.
That's the original.
Mhm.
So it's not log of x.
Log has a base 2.
Oh, okay.
So this original graph has to have a base 2.
That's
Vertical asymptote. It's the line that we cannot cross. So it's x equals negative 2. We have x equals negative 1 here. What's wrong with my pen? X equals negative 1 is here. Give me 1 second.
So we can't have a graph be just log of x.
We can.
But, it depends
But
on-
depending on what is given, you write that is the original graph. Dua. This is the original graph. I didn't do any transformation yet. It says negative 1 here, 0 here, negative 2 here. This is the line that we cannot cross. So a graph has to be one side of the graph. So this point, we shift 1 here, and then we shift twice here. So you're shifting our x-intercept 2 units to the left. This is what it means, two left transformation. So we are doing the same graph, but this time it's here. So this is what we get. Log base 2 x plus 2. Please.
Don't log graphs, like force transform, it always goes to 1.
Always goes to x value 1. So log always has x value, x-intercept 1. Julia. When you move 1 to 0 to one place, and 0 to negative 1 to 2 places. So you move 2 places to the left, and then the graph is here, and this is the line that we cannot cross. Our graph has to be before that, not after that. Okay, you try one. We have 2 transformation now. But it doesn't matter, it just moving x-intercepts. 2 is up, down. Up, down is for exponential. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. The original graph, let me draw for you. This is the original log base 3 of x. This time I'm saying it's 3 because we are given base 3. Stephanie. You raised your hand, right? No? Okay. Go ahead. Minus 5 inside the parenthesis next to x. Which direction? Right 5. That means we get vertical asymptote from here. What is a vertical asymptote? X equals 5. And then you have plus 2 single.
When you said something was opposite, so when is it opposite?
Opposite mean exponential head horizontal from up down.
So
The opposite of horizontal is vertical left right.
So it doesn't affect that.
Right. Transformation is unchanged.
Okay.
Single number means up down. Next to the x inside the parentheses means left right. So plus 2 up 2. So let's do the vertical asymptote first. 1, 2, 3, 4, 5. This is the line that you cannot cross after the transformation. So where is our new point? This point we are moving.
Okay, so it's gonna be
1, 2, 3, 4, 5. 1, 2.
the new point would be 6, 6.
So this is our new point. 5 right, 2 up. Log base 3 x minus 5 plus 2. Please.
So, next to the log, I think it's called base head.
Argument.
Yeah, no, the base.
Oh, base is the leg.
So the 3 in this case, I know the difference like between 2 and 3. So what role do they play with that?
The bigger the number, the more closer they are to the x-axis.
Okay. Oh, yeah.
So look at this one. I go a little bit far from the x-axis, and this one I go a little bit closer to x.
They recognize that in the final. Yeah.
No, like the shape is main thing. If you have the shape, it's fine. Vertical asymptote. So transformation is same for every function. Plus minus means left, right, inside, and outside plus minus means up and down. And we have a negative, it means negative in the front means reflection about x-axis. The same transformation, same everything, just the graph is little bit different.
For the log, the negative would be in front of log or in front of the parentheses.
It depends.
So it can be either.
Do you remember from the exponential? If you have a negative in the front, it's a reflection about x. And if you have a parenthesis on the power, it was a reflection about y. So it becomes a fraction, right? The same concept here. If you have a negative in front of the log, it will be a reflection about x. But if you have a negative here, it should be reflection about the y. So let's see what is next. So these are the two actual graph. And now we have a reflection on the front. So we have a negative in the front. It will be the other side of here, the negative side. Reflection about x, right? We're just flipping. And do you remember when you have all the transformation, which one is supposed to do first? Always reflection comes first. And then move the reflection left, right, up, down. So this is the original one. Log base 3 of x. Reflection about x-axis means it becomes this. Negative log base 3 of x. So just putting this below x and this was above x. Reflect. Because our mirror is here. That's the mirror. And now this reflection we are moving. -5 next to x. Which direction? That means what is our vertical asymptote? X equals 5. Plus 2 single. 2. Let me make this bigger. 2, 3, 4, 5, 6. So we have 1, 2, 3, 4, 5. This is the line that you cannot cross. And you're moving this x-intercept where? From here we go 1, 2, 3, 4, 5, and then 1, 2 here. That's our new point, and it's a reflection. So we are going to draw this one. The original graph has bigger part below, smaller part above. So that means here smaller part should be below, bigger part should be above. Negative log base 5 x minus, so log base 3 x minus 5 and then extra 2. So you have to memorize the shape. The shape for the exponential, the shape for the logarithmic. And then from before, do you remember absolute value, cubic function, square function, and what else we did? Absolute value, cubic, square. We learned 4 different functions, right, before? What are the other ones?
Right.
Line? Huh? I don't remember the graph, but I remember we have x square, x cube. Then we have absolute value. Oh, square root. So now you need to know what is exponential and what is log. So 6 different shapes you must remember them. Try this too. ln and natural log, ln and log, they're same thing, same shape, same everything. It is a different, special type of log, but they have the same concept. And in the final exam, there's either one question from the log and one question from the exponential, or that's both.
So it's still gonna say the same process.
Same thing. Do I have more? Nope. Oh, let me take attention on this. Angel here, Stephanie here, Mary Elvis, Chris here, Cassandra here, Angie here, Parker here, Tenzin here, Yaribel here, Julia here, Kevin here, Gerald here, Vansh here, Yvette here, Ryan here, Christian here, Ian here, Joel here, Janelle here, Dunhill here, Isabella here, Dua here, Nazima here, Simon here, Matthew here, Cindy absent, Melanie absent, Tony absent, Shri here, Jocelyn absent, Jessica absent. Ryan, what do you do when you have a number next to the x? Good job, right one. And since you are going right one, what is your vertical asymptote? You set this equals 0, and then so for x equals 1. Remember, asymptote is a line, so it has a variable equals a number. So the original one is here, log, sorry, this is ln of x. You are shifting this just here, and a new asymptote is this one, ln of x minus 1. Did all of you have the same graph? Did you draw the same graph? You do?
Yeah.
Great. Now the next one, who would like to try? Angel, go ahead. reflection about x-axis. And you have +1 inside. Left one. So what is a vertical asymptote? X equals -1. If you just write -1, 1 point will be deducted.
Down to.
Down to. So the original one is here. ln of x. The reflection, the bigger part goes here. The smaller part comes here. So negative ln of x. You cannot cross -1 line. And you're moving your x-intercept
Left side by one.
left one, which is here,
Go down twice.
1, 2 here. So this goes up and this goes this way. Reflection just give them negative ln x plus 1 minus 2. So in the exam, I'm going to ask two. One for the exponential, one for the log. Do the transformation for both. Is there any question on transformation? Do you have any question? No question from anyone? Now comes the properties of log, which you need to memorize. The first one says, if you have log base b with the argument b, as long as you have the same thing with the log, all of them cancel out. It becomes log. Second one says, if we have argument 1, log 1 is 0. What does it mean? It means our x value is 1. When x is 1, our log function is a y value 0. That's why we have the x-intercept 0 here. X-intercept 1 here. When our x is 1, our y is 0. We get an x-intercept. The next one says when x is 0, the log doesn't exist. It doesn't exist. When our x is 0, we have an asymptote, particle asymptote. So log doesn't have any value there. Log 0 doesn't exist. It doesn't mean this log or natural log. Both log doesn't exist when our x is 0. So log 0 doesn't exist. Log of 1, the base doesn't matter what is your base. Base could be any number. But when x is 1, your y value is 0. So log 1 is 0. And when you the base and you x the same thing, it becomes 1. These are the 3 things we use a lot in log. So these are special. These are basic properties. Next comes multiplication, division, power properties. If inside the log you're multiplying 2 things, you can distribute your log, but if you do the multiplication, turn into an addition. The log of any base and argument has multiple things multiplying, we can separate each of them by putting their individual log to them.
Is an example of multiple arguments. Multiply.
For example, log of 2x.
12.
It means log 2 plus log x. Same thing, if you have division in your argument, we can separate them, but this time we need to subtract the log. So this division, when you divide, we get less. Same thing, when you subtract, we get less. So in division, we subtract the log. In multiplication, we add the log. And then, remember I said log hates power? Anytime you have a power with the log, the power comes down. And we use that to solve exponential equation. Log cannot have power. Power comes down when we have a power in the log. The next one is a cool one. Most calculator doesn't have two base property. If you observe a calculator, our log has only one base. So in here, if we have base and argument together, you cannot find it in the calculator. Not in most calculators. Some calculators do, but most calculators don't have this property. So in order to find that in the calculator, mathematician found a cool method. It says we can put log for both of them, log of the arguments divided by log of the base, you get the result. It doesn't matter which log you use. You can use normal log or natural log, get the same result. For example, let's say you want to find what is log base 2 of 5. In the calculator, it's not possible to do so. So to find this number, we can do log 5 divided by log 2. That's the answer. Look at here. This log doesn't have any base. When you don't have any base, you have 10 base, invisible 10. So our calculator has base 10. So in order to find log base 2 of 5, we can write log base 10 of 5 divided by log base 10 of 2. So in the calculator, we simply write 5 log divided by 2 log. And this answer is 2.3. See? Now you know how much is that thing. Before we didn't know. So that's why this is a cool property. It's useful to find the numbers in the calculator. Inverse property. It's saying that if you have power comes down. And when power comes down, you'll have to log base B and B. This one. We have log base B with the B power X. Do you have any question?
Are we gonna need to know the change of base for the exam, or are we gonna be allowed to use a calculator?
You need to know because 1 point will be using change of base and 1 point will be for the final answer. So log hates power. Anytime it sees power, it comes down. So we get X log base B of B. But then log, remember the first rule. If the base and the argument are the same number, they cancel out, they become 1. In other words, you get X back. So this is what it's saying here. If you have a power and the argument and the base are the same, the answer is only the power. Because the base and the argument B, they cancel out. The next one is saying, if we have base with the power, and argument also with the power, and base and power, they're the same number, all of them cancel out, like BB, and you have X on the top divided by Y on the bottom. The last one says, if you have the power, the log of the power and your base is B, as long as the log base and your base are the same number, they cancel out, and you left it only the argument. So these are all the properties you have to memorize. Okay, so write them down in a flashcard and look at them every day for 5 seconds, 10 seconds, 1 minute. If you keep looking at them every day, again and again and again, they'll get stuck in your brain. One-to-one property says as long as we have only two base, so two log on each side of the equal sign, and we have the same base, you're allowed to cancel them. Just like the exponential property, if you had b to the x over b to the y, same base means you're allowed to cancel them, and it said x equals y. It's true for log also, but you have to have only one log in each side. So one log on the left side, another log on the left side, and we have the same base, you can cancel them. And whatever remains, that's can go to one another, solve for x. Any question on any of the rules? No? Okay. Now have some practice.
I'll be able to go back. I'll think like
Yeah. Simplify each log. So these are big numbers. We have no idea what they are telling us. But if you simplify, you'll see they're actually giving us some simple numbers to work with. Just log means log has an invisible base 10. The first one doesn't have any base. It means it has an invisible base 10. So how can you simplify this? If A looks harder, then start with B. B is easier. If it looks confusing, let me rewrite that for you. We have log base 3 with the 3 square. The 3 has a power 2. What happens to the power 2?
Does the log base 3 so the 3 become 1?
When you have the same base and same argument, they cancel out. So what is our answer?
Oh, is that 1 square? Equals 1, which is 2.
You don't write 1 square. It's if you want to do it properly, then you have to bring the power down fast. So it's 2 times log base 3 of 3. So it's not actually power, it's times. 2 times 1 gives you 2. Property number 1, the first rule on the 1, and inverse property 1. So 2 rules. We use 2 rules here. The first rule is the power rule. Log hits power, so power comes down. And the second rule is as long as you have the base and argument at the same number, it cancel out the log. 0 to 2.
In the first one, we have to make the base 10. No.
10 is there, it's invisible.
No, I'm saying
Can you direct 100 in terms of
that's
10?
what I'm asking.
Since our base is 10, our goal is to direct 100 in terms of 10 so that we can cancel the log.
Oh, okay, so you have. Oh, sure.
If you're done, I have more. Are you done copying the rules?
Yeah, I'm just trying to figure out which topics. What, so the first one, log 100.
So log 100, you have no idea, right? But you do know that that log has a base 10.
Oh, because the.
Invisible means it's 10. So can you direct 100 in terms of 10? 100 is 10 what? 10 to the 2. So we write log, the invisible 10, and 100 becomes 10 squared.
Alright, so if we don't see a base next to log, we know
It's 10.
If
It's
we don't
always 10.
find base next to LG, it's
E,
okay.
Ln. So see, when the base and the argument become the same number, they all cancel out. And there's only 2 left. That's the answer 2. Amazing shortcut. It's stuff like this one. It's in the details. But you have to know the details. What is 100 in terms of 10? 10 to the 2, right? So 10 squared. This 100 is 10 squared.
Okay.
So 2 comes down, we get 2 times log 10, 10. And then log 10, 10 cancel out. So you can do in details, or you can simply do the shortcut. Cancel the 10, 10 with the log. Whatever remains, that's the answer. On the next page, C and D. Start with D, because D is easier. No math needed. You look at your list of rules. Which one? D? Not 3. What do you have? You have 3 to the power log base 3. And it has a 4x.
So they still cancel if it's the other way around, the opposite the power with the base 3.
Yeah.
It will change
The position, it doesn't matter. Log can be on the power or log can be on the base. As long as you have the same number before log and after log, you can always cancel them.
It doesn't matter if log is in the power. And that should become 1.
So this whole thing, let me should use pencil. This whole thing turn into 1. So what remains for us? That's our answer. We didn't even do any math. Here no math is needed because we are applying all the rules that log has. So log is a machine. It has so many functions. One of the functions says if you put log on the power on the same base as the base of the log, cancel out. What can we do in C? Chris.
Log base 3, parentheses 1 minus log 3. Looking at
Oh, you want to apply the rule. Okay. So minus log base 3, 81.
Yeah.
Okay, but you're not done, right? Parentheses will be given. Here they didn't give you the parentheses.
Is that negative log base 3?
Negative what?
Negative log base 3.
Uh-huh.
8.
It's 81, not 8.
8.
Huh?
That's why I said 80 because aren't you subtracting?
No, log doesn't work. It's two machines.
Oh, never mind.
You need to use the log property. Point x is 1. What's the log? 0.
So it's a negative log base 3.
So this whole thing becomes 0.
And we will rewrite 81 to as 3 or
Good. See, we have no idea what is log base 3 of 81. So we are going to rewrite 81 using the base 3.
So we can't have log in the answer.
Right. Because we are simplifying log. So this 81 is 3 to the 4.
and now we'll cancel log 3 and and we'll have
So all of these cancel out. What is left? Negative and 4. We have negative here and from there. And all of these, they cancel out. So this one is saying our x value is 1. Point x is 1. What is the y value for the log? Look at the log function. Look at the graph. Point x is 1. What's the y value? 0. That's why log of 1 is always 0. Always 0. Who is confused? Anyone? Nobody's confused yet? Great. Let's do more. One example. You're confused about what? You're joking or you're really need help?
Can I do the first?
Sure.
As you said, there is unlimited 10. And now we can rewrite 1 over 1000 as 1 and 10 with power negative 3. Yes. And then the answer will be negative.
Perfect. We could do the left one same way.
We wrote that out. Just can't do it.
You don't have to picture it as having a conversation. You write it down so that you can see it. Try it on your own using that thinking.
Oh, and then I have to.
Same as the previous one. It's a division, right? So in division, what do you do?
I don't mind.
Come on, Chris. We did the same thing on the left. On the left, you have 1 divided by 81. Here we have 1 divided by 1000. What's the difference? The only difference you see is in here I didn't give the parentheses. Here I gave you the parentheses.
And you didn't give us a base. So we have to remove the base is 10. I have a question for that. Why, like,
Remember, like I said before, when E and L they're next to one another, they cancel out.
yeah,
They're almost next to one another. There's only one problem.
there's a
Between them, we have a fifth root.
Yeah.
How can you rewrite fifth root so that there will be no space between L and E?
We can write as E is power 1 over 5.
See, fifth root is same as
Yeah.
1/5 power.
Right.
So rewrite.
And then we cancel and then the answer will be 1 over 5.
When E and L they don't have anything between them, they always cancel out. So this one, the first one, you can do 2 ways. If you want to follow the left one, it's log 1 minus log 1000. Right, Chris? Just like the previous one, your idea is split them. Now, anytime you have a 1 for a log, what do you have? 0. And for the next one, we know our base is 10. So we need to read 1000 using 10. 10 is 1000 is 10 to the what? 10 to the 3. Thank you. So log 10 cancel out. We have 0 minus 3, which is negative 3. That's one way of doing it. Now let me show you the second method. We can rewrite this using 10 to the negative 3. Because 1 over 1000 is same as 10 to the negative 3 power. That means it's only one line. This is 10. So log 10 cancel out. And our answer is negative 3. So you can do it using details method, or you can simply rewrite your whole thing, and then the next one is answer. I believe so. I combined everything, 12.5 to the rest. For F, as long as E and L have nothing between them, they cancel out. So we have a problem, root 5. So we need to rewrite the root 5 into exponential format. Square root of 5 is what power? 1/5 power. And now see, we left E and Ln alone at home, to one somewhere, and now they're fighting with one another. When he came back, oh man, nobody's there. Except for 1/5. Do you have more rules? Yeah, you do. But let's simplify. All of these are called simplify the log. Okay? The direction says, observe, use the properties of log to simplify. So when you see this type of question and it says simplify, means you cannot have log in your answer. You need to consider the log using the log rules. The next one says expand. Expand means we are given only one log. We need to have multiple logs based on how many things we have in the argument.
And we don't simplify.
If it's simplifiable, simplify.
Oh,
Otherwise, no.
Log to be log to 3, log to X, log to Y.
Between them, what do we have?
plus sign.
No.
Good, plus. So we can distribute them, but between them we have to put addition. So log base 2 of 3 plus log base 2 of x, and the last one is log base 2 of y. Nothing we can do here, so we stop.
Does that?
In the final exam, we'll have at least one of these.
So, for example, if we had log base 2 of 2xy, then that would mean that the first one cancels out, so that actually would be log
One.
base 2 of x.
But you want to
Yeah,
cancel out,
it
to become
becomes
1, right?
Yeah.
So 1 plus.
Okay.
You have
So
to write your 1.
just get rid of the 1. We have to put it there.
So it's a term to keep it. In multiplication, we ignore 1. But in addition, we have to see it. The next one. Depending on how many things you have in your argument, you have to have that many log.
Wait, can I ask, what if they put log base 2 and then they put parentheses 1x? Did they do that?
So log 1.
That would be 0.
I mean, log 1 is 0, it is invisible.
So they're not gonna do that.
Right. So this time, how many things you have in the arguments? How many things we have?
5.
5. So how many logs we have to have in our answer? 5. And in division, do we add or do we subtract?
Subtract.
And in multiplication? Yeah. So we have multiplication on the top, so we have 2 classes. But we have so many division. For every division, we have to put minus.
Are we gonna put like the division and then on the top we put the ones that are adding and on the bottom we put on the bottom?
Division means subtraction in the log.
Okay.
You said on top we will divide it. Oh,
So let me do one example before you do that. Let's say you have log base 2, 3 over xy. Or let's say 3z over xy. Okay? So we have 1, 2, 3, 4 things. That means we are going to have 4 logs. Log base 2, log base 2, log base 2, log base 2. We have 3z x y. 3 and z is multiplying on the top, so between them we have a plus. But for every bottom, we have 1 negative. So for x, it's a negative. For y, it's a negative. Everything on the bottom gets a negative sign because we are dividing by those. Yes.
So next to it, like where we put the 10 next to log.
You don't have to.
Like it's just a few.
We put 10 when you simplify.
Would
But
that,
here we are not going to simplify, nothing to simplify here.
would that come out in calculator? Like if we did right?
Calculator log has base 10, it's given.
Right.
So
Base 10.
we don't have to write log base 10 here, which is like log.
When the base is not given, you don't have to write any base. But we always assume our base is invisible 10.
when it's needed, we can do it. Now here with the power and the square root, should we simplify?
Of course. Every power and every root, you need to simplify.
Do we have to write it like that, or can we just do minor parentheses, small parentheses, small one?
It cannot have parentheses. So into distribute it's minus.
So that is like the simplest.
That's why I don't show the minus in parentheses. I simply say whatever you want the denominator, they all get minus.
That's right.
So it's log.
Let them finish.
Okay, so like.
Are you guys done? How about my right side? How are you guys doing my right side? Remember, these are final exam questions. You will see them in the final exam. Something like this one. Complicated with everything in it. Ready? Go ahead, Nazima, tell me.
Log 4
Mm-hmm.
plus 3 log
No, fast, just write everything.
log x
X cube.
log 5 minus log y squared
Log y square.
and minus log square root.
Log square root of z. Now square root of z, we don't want the square root, we want to rewrite as a power. So it's z to the 1/2. And now see how many powers we have. 1, 2, 3. Log hates power. So what is our next line?
Now we'll move 4 plus 3 log x.
So let me change the color. 3 comes down. We get log x.
Log 5
Log 5.
minus 2 log
Log y.
minus, we write just out
1/2
log
log c. And now this is the final answer. Because it cannot simplify anymore. So anytime log has a power, it cannot leave the power. You must bring the power down.
Kind of recommend, like that's why it's just log.
What do you mean?
Is it just log that applies to, or that?
No. Log Higgs power. That's why we use the log in order to solve the exponential equations. I think I have one more. One more. And this one is similar but not same.
The square will write as separate two square roots.
How many logs do you need here?
Or
No, square root of y7 and square root of z to the 5. That's what I said. This one and the left one is similar but not same. On the left one, below the square root, you had one term, but here, below the square root, you have two terms.
Can we break 1 to the 7 into 2 square root?
And then you need to rewrite into exponential form. Sorry, in the exponent form.
B. Well, what for the y is the power of 7? When we write this log y over 7 is the power.
7 is whole number, and here is square root.
Yeah.
So what is square root of y to the 7 if you write in terms of power?
Yeah, actually, don't know.
What is square root of x in terms of power?
One of it.
Square root of x. Square root of x is x to the what? X to the what? 1/2. Now, if you have square root of x to the 3,
X to the power of like 1.
but 3 is a whole power, and square root is a fraction power. Do you remember the rule? Nth root of x to the m, it's x to the what?
M over n.
M over n. Do you remember that?
I just don't know how we write it.
If you have both power and the root, power goes on the top, root goes on the bottom. So what goes on the top? This is 3. What goes on the top? 3. What goes on the bottom? What is square root? Square root is what power? You do know. Square root is what power? 1/2. Any type of radical is a fraction power. Review your exponent rules from before. You forgot your rules. Any radical is a fraction power. Whatever radical you have, that's the denominator of the fraction. So square root means 1/2. Cube root means 1/3. Fourth root means 1/4. The radical is the denominator on the fraction. And if you have a whole number, that's the numerator. So for square root of x cubed, it's 3 to the 3 and denominator has 2. Review your exponent rules, you'll be fine. Stephanie, you want to try? Okay. Go ahead.
And so I had 4 logs. I had log 5 plus log x to the power of 6
Perfect.
minus
Mm-hmm.
square root of y over 7 I mean, y
Square root of y to the 7.
minus log square root of z to the fifth power.
Square root of z to the 5.
So that became log 5 plus 6 log x
Mm-hmm.
minus 7 over 2 log y.
So let me rewrite this for others.
No. Oh,
So you can see that we have, let me write it nicely. So the square root becomes half on the bottom and the whole number goes on the top is a power. So this, also let me keep this here for now. And this, all of these are powers. So now we have a final line. Log 5 plus
6 log x
6 log x,
minus 7 halves
7 half.
log minus.
Oh, I missed my y.
Yeah.
7 half log y.
Minus 5 over 2 log.
5 over 2 log z. That's the final answer. So if you're confused what's going on, review the exponent rules from before. Remember in exam 1, I gave you 35 of them. Review those rules from the review sheet. So you rewrite all those logs into power, all those radicals into power. Why? Because log takes power, we bring them down as a group. So in our next class, we are going to do more rules. And then we are going to solve logarithmic equation. So have a good day, everyone. See you all again in our next class.